Some of the most important diseases of humanity are transmitted between people by other animals, like fleas, snails, and in particular mosquitoes. Mosquito-borne diseases have changed history. So is the control of them. The French failed to build the Panama Canal because of the ravages of diseases like yellow fever and malaria. Only after the Americans controlled mosquitoes could the canal be built. Even today, 200 million people get malaria a year. 100 million get dengue, 200,000 yellow fever. Most of these diseases are in the tropics, but there are also rarer, important diseases like West Nile virus and chikungunya that can be transmitted by mosquitoes even in rich countries. For vector-borne diseases like malaria, there are two options for control. One is to try to cure the disease with drugs or protect the patients with vaccines. This patient-centered approach is more natural for physicians, and it is the approach which has attracted the most research and attention. But the other option is to go after the mosquitoes. This has been the more successful approach historically, and that success continues to this day. To explain why, I'm going to focus on malaria, but the general issues apply equally to other mosquito-borne diseases, including viral diseases like dengue, West Nile and Japanese encephalitis, and the mosquito-borne worms that cause elephantiasis. Part of the reason that mosquito control can be so successful is that the patient-centered approach isn't always an option. There are good drugs to treat malaria, but there is currently no vaccine. For yellow fever, there is a good vaccine but no drugs. For dengue, there are neither drugs nor vaccines. And even where we do have drugs, as in the malaria case, many people can have the parasites in their blood but not be sick. These asymptomatic carriers are very hard to find, yet they can maintain the parasites in the community. The idea of mass drug administration, where everyone in a region is given drugs, can work, but immigrants moving into an area can reintroduce the malaria parasites. So malaria control with drugs alone is tough. But the main reason mosquito control can be so effective at controlling vector-borne diseases comes from the biology. For transmission to work, a lot of things have to line up. For instance, mosquitoes have to get infected in the first place by biting on an infectious person, not an uninfected person or a cow that won't have human malaria. And then to cause a new case of malaria, infected mosquitoes have to bite a susceptible person, not a cow or an already infected person. So that is two bites that have to line up. Moreover, those two bites have to line up at the right times. Something I find incredible is that all the important vector-borne pathogens take some time to develop in the mosquito. During that time, they are not infectious. For malaria, this period varies between 10 days and many weeks, depending on a lot of things, but particularly the temperature experienced by the mosquito while she is incubating the parasite. 2 weeks is pretty average. Think about what that means. For 2 weeks after she got infected with malaria parasites, a mosquito is not dangerous to humans. Only after the parasites finally burrow their way into her mouth parts is she capable of starting a new infection. 2 whole weeks. In most places in the world, that is longer than the average mosquito lives. It is one of the great ironies of malaria. Most mosquito populations do not live long enough to transmit malaria. Hardly any mosquitoes will ever encounter malaria, maybe just a few %. And of those, hardly any will survive long enough to pass it back to humans. So lots of reasonably improbable events have to line up for malaria transmission to occur. A mosquito has to get malaria in the first place, then she has to live long enough to become infectious, then she has to bite on a susceptible person, and so on. This means that if you can reduce the number of mosquitoes, if you can shorten the mosquito lifespan some more, or if you can reduce the chances they will bite a person, then you can have a big impact on malaria transmission. This is all because if you make a lot of low probability events even less likely, the multiplicative effects can be very large. And that is why mosquito control can be such a good way of controlling a vector-borne disease, and often way more effective than treating patients. And there are lots of ways to do mosquito control. You can try to reduce mosquito densities. One important way to do that is to attack mosquitoes at their breeding sites. Mosquito eggs and larvae live in water bodies. Large-scale environmental changes like draining swamps can be highly effective. This is how malaria was eradicated from much of Europe and the United States. It is also possible to systematically poison larvae. In 1930, in northeast Brazil, the African malaria mosquito, Anopheles gambiae, was accidentally introduced off ships from West Africa. It spread across an area the size of Switzerland and led to vast malaria epidemics with hundreds of thousands of cases, perhaps 20,000 deaths, and mass panic where people just ran away. Incredibly, the Brazilian government and the Rockefeller Institute set out to get rid of every last mosquito. Fred Soper, one of the heroes of tropical medicine, organised a vast army of people to put insecticides in every puddle in the area. Remember, the size of Switzerland. And after several years, it worked. They got rid of every last mosquito. Of course, that begs the question of why that can't be done today. The insecticide they used then, something called Paris Green, would be considered environmentally damaging today, but we do have organic pesticides available now. No, the biggest hurdle is the logistics involved in mapping and treating and continuing to treat every last puddle. It is hard to imagine that in the political climate of today, such logistics could be achieved. So that's an example of successful larval control. From a disease transmission perspective, however, even more bang for buck comes if you can go after the adult mosquitoes when they come into houses at night to feed on people. They can be blocked from biting people with bed nets or window screens. They can be killed or repelled with insecticides or bed nets or insecticides sprayed on walls. Insecticide solutions can be very effective. A challenge is the need to reapply them every few months, at least on walls. These days, the insecticides on bed nets can be made to last as long as the bed nets, about 5 years. But the main problem is that the mosquitoes become resistant to the insecticides. In the 1950s, DDT was hailed as a solution to malaria. It was miraculous what happened to mosquitoes when it was sprayed on house walls. But it was only a few years before people started to see mosquitoes walking around on DDT-treated surfaces that killed all of those mosquitoes only a few years earlier. Today the search is on for alternatives, new chemistry and new technologies. Matt Thomas and I here at Penn State are working on a fungus we can spray on the walls that will penetrate into mosquitoes and eat them from the inside out. And there are other approaches being worked on, from infecting the mosquitoes with bacteria that make them immune to malaria, to genetically modifying the mosquitoes so they cannot reproduce themselves, or to make mosquitoes that produce compounds that kill any malaria infections they pick up. But you might be wondering, if there are all these options and if vector control can be so effective, how come we still have malaria? Well, first of all, we don't have malaria in many places we used to. It's gone from Europe, from North America, Taiwan, Russia. So vector control can work. The problem is the places where it still remains. Usually they are grindingly poor. Malaria is easy to eradicate if you have enough money. Well-sealed, air-conditioned hotels are not the place you get malaria. Malaria today is a disease of poverty. What makes things worse is that in those places with malaria, they often have an awful lot of malaria transmission. There are parts of Africa, for example, where people are getting bitten by infectious mosquitoes 3 or 5 times per night. That's right, they get exposed to malaria 3 or 5 times per night. That's 1,500 infectious bites per year. With transmission that intense, well, imagine control measures that drop the number of infectious mosquitoes by 99%, something that could be achieved only with a huge amount of money. That would still leave 15 infectious bites per person per year. Still a huge amount of transmission, a huge amount of disease. So the bottom line, vector control can be highly effective and even lead to eradication, so long as the transmission is not too intense to start with.